concerning the specific enthalpy of moist air. As for the moisture content, the reference of mass is the mass of dry air. So the unit of the specific enthalpy of moist air is a unit of energy, so joule or kilojoule, divided by the mass of dry air. The specific enthalpy has no absolute zero. It's not like the entropy that has zero, that is properly set at 0 Kelvin. So the origin for enthalpy is arbitrary and is defined by conventions. The usual convention concerning moist air is to set the origin of enthalpy for liquid water at 0 degrees Celsius, and concerning the dry air is to set the origin of enthalpy at pressure of 1 bar and a temperature of 0 degrees Celsius. So when we want to express the specific enthalpy of a given moist air, so an air that has a given temperature and moisture content, and here assuming that the pressure is 1 bar, we need to integrate the variation of enthalpy from the origin that is set by convention to the conditions at which we are, and to express this per unit of mass of dry air. So if we go into the detail, the specific enthalpy of a given air is equal to the enthalpy of the dry air part of this moist air. So the integration of the Cp of the dry air by the difference of temperature from the origin to the temperature at which we are, to which we will add the specific enthalpy that is due to the water vapor that is in this moist air. And this water vapor has two components in its enthalpy. The first one is the phase change enthalpy, so what we usually call latent heat of vaporization of water at 0 degrees Celsius, because the origin is set for liquid water. And to this we also add the variation of specific enthalpy of water, but of vapor water, due to the fact that we are not at 0 degrees Celsius, so the integration from 0 to the temperature at which we are of Cp of water vapor times the temperature. Note that the Cp, it's not the usual Cp of water that we use, because the usual one is for liquid water. This is the Cp for vapor water, and this is around 1.92 kilojoule per kilogram Kelvin. And the specific enthalpy that we have expressed here is expressed per unit of mass of water, but the specific enthalpy that we want to express is expressed per unit of mass of dry air. So we multiply this by x, so the moisture content, that is the ratio of mass of water per the mass of dry air, and therefore we have here for the right hand side term the specific enthalpy that is due to the moisture content, but expressed per unit of mass of dry air. We can notice we can do two assumptions here. The first thing is that the temperature is usually quite close to 0 degrees Celsius, or at least close enough so that we can consider that the Cp of dry air is constant, so we can remove it outside of the integration and have a simplified integration by this being the direct product of the Cp times the temperature expressed in degrees Celsius. The second assumption that we can do is that the enthalpy that is due to latent heat is way bigger than the sensible enthalpy that is due to increase of temperature of the water vapor. So inside these brackets, this term is much bigger, and the other term can be neglected. So in that case, we can approximate the specific enthalpy of the moisture as being the Cp of dry air times the temperature, and this is expressed in degrees Celsius, plus the moisture content times the latent heat of vaporization of water defined at 0 degrees Celsius. So Cp of dry air and latent heat are constants, so it means that the specific enthalpy of a given moist air can be expressed as a linear function of temperature and of moisture content.